Honorable dignitaries, delegates, respected CEO, principal, teachers, dear students and participants. I feel privileged to welcome you all on behalf of the organizing committee of the 2 Days International Conference on Emerging Technologies 2022. American sociologists once stated, technology, like art, is a soaring exercise to human imagination. Here, Royal College of Engineering and Technology is opening up to you the platform to enunciate the imaginations in you and to preserve it. It is a mark of our undying tradition to invoke the Almighty at the beginning of an important event. Like the great philosopher once said, the function of prayer is not to influence God, but to change the nature of the one who prays. I call upon Ms. Nasiva Navshad for the prayer.
Jagadishwara Dayanide Kanyename ഇരുൾ മൂടുമീ ജീവിതത്തിൽ തെളിയേണം ഇരദീപങ്ങൾ ഒരു ജാതി നമ്മൾ മതം ഒരു ജഗദീശ്വരായിതേ ഇരുൾ മൂടുമീ ജീവിതത്തിൽ ജഗദീശ്വരായിതേ.
I would like to invite Dr. N. Icet 2022 convener, the Sports Ministerial Department, to formally welcome the gathering.
Thank you, ma'am. Thank you. Good morning to all attendees. On behalf of the organizing committees, I would like to welcome all of you for the International Conference on Emerging Technologies, ICET at Thrissur, cultural capital of Kerala, God's own country. The ICET is an annual international conference to be carried regularly by Alim sir for this inaugural function. I welcome you, sir.
Thank you.
Thank you, sir. I would like to welcome our principal, Dr. Devi B, for this inaugural function. I welcome you, ma'am. Thank you. Mayor Dr. K.G Smitha, Senior Lecturer, School of Computer Science and Engineering, Nanyang Technological University, Singapore. I welcome you, ma'am. Hearty welcome to you.
Thank you, sir. Thank you, sir.
Yes, ma'am. Thank you. And under the theme of the conference, in which the future, meaning visualize something for the future, the young budding engineers have to think and do something for the technological development. The conference features a rich program, including a keynote speech to be delivered by Dr. K.G Smitha, Senior Lecturer, School of Computer Science and Engineering, Nanyang Technological University, Singapore, and another faculty member from Curtin University, Dr. Chithirai Selvan, sir. He is also will be joining us shortly. And on behalf of the organizing committee, I welcome you also, sir. And the track-wise invited speeches by the eminent academicians and experts, industrial experts in the field of remote sensing, artificial intelligence, and also on the soft computing approaches. Dr. G. Kumar from Beltech University. He will be delivering a lecture on remote sensing and GIS in groundwater management. And Mrs. Vidya from PSG College of Technology, Coimbatore. She will give a talk on introduction to mathematical modeling and control system design. And Dr. Leena, NSS College of Engineering, Palakkad. She will be delivering a lecture on soft computing approaches for engineering applications. And Ms. Vijayalakshmi from Karunya Institute of Technology and Sciences, Coimbatore, and she is planning to deliver a lecture on artificial intelligence in medical field. And Mr. Raisin Joy, a research scholar from GEC Thrissur, and also he was the former head of the Department Mechanical Engineering of our own institute. He has a plan to deliver a lecture on artificial intelligence prospect in the mathematical engineering field. And the International Conference on Emerging Technologies offers a special opportunity to bring together professors, researchers, and scholars and serves as a platform to deliver innovative research results and latest trends and development in the field of science and engineering. All accepted and presented papers in this international conference will have the opportunity to be published in the proceedings with ISBN number. In fact, we are trying for the Scopus Index also. Around 45 research papers have been accepted by the organizing committees and for presentation in 5
opportunities and programs we offer students. At the same time, personalities. Our college was established in the year 2003, and it is very great privilege to announce that our college is marching towards the silver jubilee. Strongly believe that it is our duty to investigate the future into emerging technologies to create a global outlook to face the challenges of changing world. I hope ICET 2022 should be a continuation of our RCET greatest mission. Hereby I am officially inaugurating the International Conference of Emerging Technologies 2022. Thank you all.
Thank you, Selvan sir. Now, we are happy to announce that the session has been inaugurated officially. Now, we're moving on to one of the most awaited session of the day. It is our honor to have with us Dr. K.G Smitha, Senior Lecturer, School of Computer Science and Engineering, Nanyang Technology University, Singapore. K.G Smitha received her BTech degree in Electrical and Electronics Engineering from Calicut University, India in 2002, the MA degree from Nanyang University, India in 2004, and PhD degree from Nanyang Technological University, Singapore in 2010. She was a lecturer in Amrita Vishwavidyapitham, Coimbatore, India from May 2004 to November 2004. And she joined School of Computer Engineering at NTU, Singapore, as a postdoctoral research fellow in September 2009, and later as a research fellow for teaching in 2013. Her main research interests are in the areas of low complexity and high-speed GSP circuits, computer arithmetic, and signal processing brain-computer interface. It is my pleasure to invite Smitha ma'am for the keynote address. Ma'am, please.
Thank you very much for the wonderful invitation. Good morning to each and everyone present over here, the dignitaries, the principal, as well as all the students and faculty of Royal College of Engineering. A warm welcome from Singapore. And myself is Smitha, as has been mentioned earlier. I'm indeed honored to present during this declared International Conference on Emerging Technologies, which is held in your college. And the topic that I'm going to discuss will be on brain-computer interfaces, which is one of the passion that I'm working towards with. So certain projects in this, I would like to share more related to this. Let me come up with my slides before I go on with the same. Okay. I hope you're able to see my screen. Okay.
Yes, ma'am.
Thank you very much for ascertaining what I had over there. Okay. Myself is Smitha, and today the presentation is on the brain-computer interface systems, its overhead application. As mentioned, I'm coming from Nanyang Technological University, and the topic that I have over here. Okay, so please bear with me for 1 or 2 minutes before later to NTU and my school, before I go on with BCI or the brain-computer interface system. Myself is coming from Nanyang Technological University. It's one of the second oldest autonomous university in Singapore, and it is the 19th ranked university according to the QS rankings, and it is considered as the first among the global young university according to QS rankings. And we have a very vibrant and vast college over here, which includes not only College of Engineering, it also includes College of Sciences, Humanities, Medicine, Business, and many others over here, including even a teaching institute inside this particular campus. See, these are a few glimpses of our campus just to excite some of the students over there in case if they want to come over here to do a master's or a PhD. So that's also one of the points over here. Coming to my own school, which is a School of Computer Engineering and Computer Science and Engineering, I might have made a mistake, Computer Engineering, because when I started studying in this school, it was just a School of Computer Engineering. It was later termed the School of Computer Science and Engineering. This is also one of the best schools among the different universities for computer science. And we not only have simple computer science degree over here, we have a degree in data science and artificial intelligence. We also team up with the School of Business and School of Economics and School of Physics in order to order double degree or a double degree in both the fields. So it merges computer science with that field and will give a double degree in both the fields. To our school, please go on and search over there. It may not be for all of you, but brief history related to my school and the university that I'm the talk on. Before going on with what I have over here, I would like to present a small video. I just want to make sure that the video sound is audible to all of you. Please let me know if it is not audible.
Ma'am, I guess it's not audible.
Okay. I'm just trying to see if I can make it audible by any means. If not, then I myself may have to. There are settings in Zoom and the Teams that I know how to check, but with Google, this one I'm not so sure about. Sorry, unfortunately, everything went away. Okay, in that case, I will not go to the video. Maybe I'll directly start with the slide. It's actually interesting video where I could have seen brain-computer interface with help of a small monkey. What the monkey was doing over there was that monkey was trying to put the joystick over there. there is a implant of a sensor on monkey's brain, and it's picking up signals from its brain. And the incentive that the monkey is that he's getting a banana juice through that particular window that he's. You can see that particular one over here. You can see the monkey is drinking something, and whenever he's able to push that particular ball onto that orange screen over here, the monkey is able to get some juice. So that's the incentive that the monkey is getting. The monkey is continuously trying to move the joystick over here. One hand of the monkey is on the joystick, and monkey knew that previous time when he put like that, he got the banana juice. So next time also he's interested in getting banana juice. That's the reason why monkey keeps on buying the joystick. So the brain signals that I get from the sensor, which is implanted in monkey's brain, and understand about that particular brain signal, decode that particular brain signal, and create a predictor such that now it is not the monkey's hand movements, but in fact later on in the video, I don't know whether I can show you that particular portion of the video. So maybe you can see the visualization over here. So you can see that the hand is moving because the monkey wants to get the banana juice. So all these neuronal activities are being recorded, and we are trying to predict how the monkey is going to move it, okay? So that's what we are trying to do. So we are calibrating the decoder and understanding the neural activity of the monkey. So you can notice that right now we are showing the screen wherein which it has been wirelessly streamed such that thousands of neurons streaming, you can see it over here. And these data is being decoded and calibrated such that we can model the relationship with its hands movement and the way in which his brain is being immaculated. Right now, can you notice something very interesting over here? This connector of the joystick is now removed from this particular one. So ideally speaking, monkey is moving the joystick, but monkey doesn't know whether moving the joystick is ideally useful for him or not. But ideally, the movement of this particular white ball is because of the predictor that we have developed due to the brain signal and not due to the joystick. You can see that this connection has been removed, right? So no longer the joystick is working. The monkey is able to still get the banana juice because his brain signal is now controlling his movement. So this is what I want to explain in few slides later on related to brain-computer interfacing. So it is an additional part from our brain which can be used in order to help people who have limited hand, leg, or any difficulties in their, or having paralysis or stroke or things like that. So actually BCI is a tool for all those applications. Now coming to the basics of brain-computer interface, you can notice that ideally we have a normal communication pathway between the brain, the muscles to execute an action. We know that from our central nervous system, we can have cognitive, perceptive, movement, and memory kind of inputs that will be going through our central nervous system, through the nerves, to the sensory organs, which can move our upper or lower limbs and do any action that we want to do. For a normal human being, this all seems to be very, very intuitive, and they are used to doing things and they don't think that this is something which is difficult. But think about a scenario wherein which a person is not able to move his arms, he is paralyzed and is not able to move the arm. Any small thing that he needs to do, he has to depend on someone else. So we have over here with the nervous system, nerves to the sensory organ. Rather, these guys are to pro and it is He'll be thinking that I want to move my arm towards the left, towards the right. If I put these the arm, be able to some of the BCI applications I have tried to provide it to neuronal rehabilitation, especially for war veterans and also for people in stroke-related issues. We can also use this in terms along with robotics. It is also used for entertainment. So think of a scenario wherein which you can control a quadcopter just by your thought process. You don't have to move any joystick. You don't have to move any keyboard or any keys in the keyboard. Just by your thought process, you can actually maneuver a quadcopter. And this is exactly what we're doing in a performance training over here in terms of cognitive behavior. We would be able to even drive a car just by looking into the screen and decoding signals from the brain. So ideally speaking, thoughts are being put into action. That's what we're trying to see over here. Before I go for some of the experiments that we had over here, let me try to introduce the basic principles behind the brain-computer interfaces, okay? So this is a basic block diagram of a brain-computer interface. So you are interfacing brain with the computer such that you would be able to do something useful out of it. So from the brain, I will be getting the data out from the brain. Obviously, that signal is going to be very, very different. So different things can take different kinds of signal from the brain. I'm not going for all the different technologies over here. My talk will be limited to EEG based. EEG is electroencephalography, and I'll be only basing my talk on EEG based brain acquisition. So we will acquire the data from the brain. We will do some kind of pre-processing. If there is any noise, we will try to remove them and understand what are those brain signals. We will extract the features out of this particular brain signal, and we need to do certain feature selecting. This is exactly machine learning, nothing major about it. Exact machine learning, getting some data, doing a pre-processing, extracting the relevant features. We all know, those who are in machine learning, we all know the key trouble is in the extraction of the feature, extraction of the selection or selecting the features, and using these features in order to model your, or perfectly model your architecture, and thus we would be able to translate that particular features into certain robotic movements or wheelchair movements or even moving a virtual car on the laptop screen. So whenever we see that it is moving, this is kind of a feedback back to the person who is actually taken the brain data from. So this kind of visual feedback or an audio feedback that the person gets will actually help him to make the system more robust, because he or she is able to understand that whatever I try to do is successful. So that gives him more confidence in order to do this in a more correct manner. So this is a correcting mechanism on the go. I can say that this is a correcting mechanism on the go. Before I move on, I just want to introduce different methods for brain acquisition, because if I simply go on with EEG, it may not be a better way of explaining. Ideally, in order to take brain signal, we cerebral brain. Because to get we require to be through a large proposed. is coupled with a partially invasive method with an electrocardiography or ECOG, and an electric tape is attached on the particular stain. Surgical method required for this, and I don't have to fully get it on the cerebral cortex. They're all intricate things which are non-invasive in nature. I'm not a doctor. I don't think anybody aware. I don't want to have it by any means. So non-invasive method seems much more better. Okay, do functional MRI that are able to understand the brain. So that is one way of mapping the brain. There are several techniques that are being running, or several procedures related to the brain image background, which goes for the fMRI of understanding the brain map. I can also do a magnetoencephalogram. That's also another one. Is functional near infrared spectroscopy, or FNIRS. This is also another method that I can use as a non-invasive method. Please note, all of these are not embedded onto your brain, but just attached to your head. That's why I'm calling it to be non-invasive. So right now, I'm showing you an EEG cap. This is not a wireless EEG cap, but it is a wired EEG cap. Right now, the one that this lady is wearing is a 128 channel EEG cap. And this particular EEG cap, if I want it attached to the scalp, I have to make sure that every electrode that I'm attaching over here is properly placed onto this particular sheet, the black sheet. And each and every one of them should be adjusted. The resistance of each of them, or the impedance of each of them, should be adjusted with the help of a gel. So it takes a long time for someone to wear this EEG cap, but we would be able to get the signals out of the brain. So I'm going for the non-invasive method of getting brain signals with the help of electroencephalography. So we're focusing on the fully invasive or the partially invasive, but I will show you used this too. Ideally speaking, there are certain rhythms in EEG. We are not looking at a very high frequency signal. We are looking at a signal which is 0 to 40 hertz. So very low frequency signal, that's what we are looking at. EEG is not a very high frequency one. Out of the 0 to 40, I have delta, theta, alpha, mu, beta, and gamma. These are different sections in the frequency range. And why am I calling this to be features? Because individual frequency bands. If I understand that my delta is higher, that means I'm in deep sleep or maybe in a coma. So then my delta signal will be much higher than in terms of its amplitude than the rest of it. But if I'm doing a mental activity, thinking, focusing, or doing a sustained attention, then my beta will be much higher than that of my delta. So I'll be able to understand through this particular features of EEG, what is the activity that I'm doing. I'll be able to segregate the features such that I will know that whether I'm doing a mental activity or whether I'm peaceful or I'm meditating or in a deep sleep. So all these things I will be able to segregate out by understanding what is the frequency range that I'm currently visualizing from the EEG signals that I'm getting over here. Before, till now, we were talking about the basics of BCI. Before I set up the platform, I just needed to give you the basics. Now I'll be talking about one of the projects that currently I'm working. The name of the project is called Nourish, and I'm a co-PI of this project. And in this project, our interest is the next generation brain-computer platforms, and it is a holistic solution for the restoration of the enhancement of brain function. We wanted to take care of the motor functions. We wanted to take care of the cognition function and the emotion function. I'm not going into the details of all of this, not to bore you. maybe I can just let you know that this is something which will be good for the rehabilitation. If a person is lacking motor activity, I would be able to decode these motor signals and help him in doing that particular motor activity I have provided. In terms of cognition, I would be able to do rehabilitation therapies, even for emotion. Let's try to take one by one so that we would be able to understand them better and at least have an idea related to what exactly a BCI and what exactly BCI-based control means. First, let me go to the motor area. EG for motor control. I can see that this is just a replication or an imaginative replication of the brain. I have to get the signals from the central part of my brain. And this part, I call it to be the primary motor cortex. So from the primary motor cortex and the premotor cortex, this is the area which I'm more interested if I want to find out what is the motor control brain signals. So brain is actually a wonderful creation of God. I can't say more able to, none of the high computing systems is still able to emulate brain with its full potential. If we still want to do that, even the high-end servers that we have till now is not yet able to do that. So you can see the vision of the creator over here. And in the brain, there are several areas. I have frontal area, I have an occipital area towards the back, and a central area, which I call it to be the primary motor cortex. The frontal area is interested more in attention, relaxation kind of signals. Your central area is more interested in the motor signals. So when I'm using it for a motor control, I would be more interested in this particular motor cortex, okay? In that way, what I'm trying to do is identify the motor signals and translate them and such that I would be able to put that into a decoder. Decoder can be a hand movement, robotic hand movement, or things like that. I can also do a motor imagery. Rather than explaining this over here, maybe I can try to show you an example. This is not done by me. This is from the Brown University, and this is one of the fundamental and most important one, which has been published in Nature in 2012. Here, the robotic arm is trying to do a three-dimensional reach and grasp movement, okay? Some of you might have already seen this video in YouTube. Otherwise, you can just search for the BrainGate Brown University, you'll be able to see this video. This particular lady whom I'm portraying over here, she is not able to move her hands for past 17 years. And what she wants is, she just wants to drink a coffee which is being kept, she just herself. She's not able to do that because her hands are paralyzed. So what I'm trying to do is that I have self connect a sensory array. It is not EEG, please note. This is a sensory array which is connected onto her brain, and this sensory array picks up her brain signals. I have already calibrated her brain signals, understood her motor signals, and have made a machine learning model which would be able to decode her motor signal left, because her brain signals have already told the robot that you need to move towards the left, automatically moves to the left. And if she thinks right, the brain will be able to move towards the right. So it is a motor movement, but she is not doing the motor movement, it's a motor imaginative movement. So it is called as a motor imagery. It's not motor movement, it's motor imagery. So you can see in the first one, she's just grasping that particular bottle. Next one, she's lifting that particular bottle. And over here, you can see that she kind of managed herself in sipping that particular one, and you can see the joy in her face. After 17 years, she is able to do that by herself. This was indeed a huge turning point in the area of BCI, whereas we could use this for rehabilitation purposes, which will actually enhance their mind potential such that they would be able to be stronger to try out many things. So this is one of the example of a motor imagery one. As I said till now, This insertion of the sensory again is difficult. That's why we went for a non-invasive technique. But even non-invasive technique of EEG, you saw that in order to keep an EEG cap, it is pretty much difficult for each and every one of us, because at least 1.5 hours you require to properly keep it, gel it, such that the fitting connection is extremely fine. Once you remove it, you have to wash your hair with shampoo, otherwise the gel will stick to each other. So it's a nightmare. There are several low-cost EEG devices which is available. Why I'm mentioning about all these things? Because there'll be several students who would be interested in doing final year projects later on. Then these are some of the tips that they can try it out. So these are low-cost EEG devices which are very easy to wear. One is an emotion epoch, another is a NeuroSky Bengate, another is MindPlay, Muse, and Neuroband. All these are different companies. They are producing low cost. When I say low cost, it's not extremely low cost, because this one itself would range from around $250 all the way to $1,000. But when I'm mentioning about the 128 channel EEG, which I had shown you earlier, that particular one costs you about 65 to 70,000 US dollars. So this is low cost compared to that, right? So here we can use this. One of the important characteristics of these are that this will be able to transmit the signal wirelessly rather than in a wire one. Now I would like to show you one of the experiments that an final year student has done. I don't want to scare you with the work of a PhD student or a research scholar, because you would be more interested in seeing what an undergraduate student can do. So let's try to see a final year project in terms of this BCI, and the student is trying to do a motor imagery EEG based game using emotive epoch. So he has won the emotive. Even though he is holding a cube in front of him, cube will not be moved. He is imagining that I am moving the cube towards the right, and he is imagining that he is moving the cube towards the left. Okay, so it is just imagination. The cube will not be moved. What I have on the screen is there are 3 roads that I have on the screen, and there is a car over here, and this car can move to 3 roads depending on whether he is imagining right or whether he is imagining such that you will be able to understand them better. So he has started playing the game. He is looking for cones, the green cones which are being kept. So right now he thought left, so it's able to move left. Why he moved? Because he wanted to grab the cones. The cones are his incentive. He will be getting more points with the cones. Now he want to grab it to the center, so he came to the center. This is all imagination. You can see that the hand is never moving over there. So again, as possible over here, such that he would be able to win this particular game. So the interest is more to the intent, seeing whether motor imagery can be done and how you can do it in a game-based environment. See, the EEG signals are very noisy. It is very extremely hard to decode them. Right now you can see a roadblock over there. It's a red signal that you can see on the screen. The roadblock is something that I want to avoid. So whenever there is a roadblock, I want to avoid it. If I hit onto a roadblock, the car or the driver will die over there. So this is kind of a gaming environment that we have used such that we would be able to do a motor imagery EEG based system. So again over here, using the EEG, and once he has from the EEG, and that has been, the features have been given as commands to this particular game that is there. The commands are move to the right, to that. So the only commands given over here is move to the right. because he has tried to put them in two ways. One is keeping the motive in this particular scenario was, if he's keeping this scenario, of course, for experiment number one, position is in such a way that he's keeping his emotive, the senses are all towards the frontal area of capture all those signals if I'm going to experiment two, because I'm doing it at the central position of my brain. So he had experiments in both ways and tried to answer even with using emotive with this low EEG device. He is able to have accuracy and an average pickup rate in order to do a rehabilitative stroke therapy for those patients who are not able to move their hands confidently. So here we are trying to let them know that their brain is still working fine. Their brain signals are still strong enough to say that they can move their hand. It is just their sensory system which is not able to move. So we are trying to give them more confidence in doing more therapeutic exercises such that they will be able to have some sort of benefit out of it, such that they will be able to have a limited movement of their limbs if they are trying to do with a rehabilitative method over here. That's what I have to let you know over here. And then I do have another video wherein which till now I showed you a software wing. In the software, we were controlling the particular car over there. In this video, again, I'll give a voiceover to the video. The person is imagining to move right. He has a hardware device that's called as a Sphero robot. So when he's trying to move right, again, he is not moving it, it's moving by itself. He's only imagining it. Now moving towards the left. You can notice that it's moving towards the right. He has kept a box over there such that it doesn't fall down because it's a spherical one. Okay? So these are experiments that we can try on. Over here, the student was more interested in the hardware sense, so he wanted to really visualize it in a hardware perspective. So that's what we have been showing over here. Till now, I was showing you details related to final year projects, what an undergraduate student can do. I am also trying to showcase to those who are interested in BCI related to more in-depth way of looking into BCI. We can even, rather than just saying that whether we are moving towards a left or right, so it is classification between left and right, I can even do the classification of speed and position of my hand movement. So here in this experiment, what we were trying to do is, can we classify between moving fast and moving slow? So can I classify between fast and slow motion? So that is decoding hand movement speed. So a person is sitting in front of this particular GUI. The GUI is not doing much. I have a center icon over here, and there will be a green dot coming onto one side, and I need to move my, I need to imagine that I'm moving towards the left-hand side, the left-hand side, in a fast manner and a slow manner. So in a fast manner means that this particular white line will be traveling much faster. If it is a slow manner, it will be traveling slower. All I just need to do is that I need to travel this red icon along with this white line. So what I'm controlling is this particular red icon on the center. So when I do it perfectly, I will find my score would be pretty much bad over there. So here our interest is to find out whether I can decode the hand movement speed and also to find out after the feature extraction classification. So here, to find out the decoding, the hand movement speed, I'm doing classification. In order to find out position, I'm doing the regression over here. So here, I'm trying to show you the details of the movement. I can clearly classify, and I'm doing the fast towards right and fast towards left. So in the second diagram over here, I can clearly segregate them in terms of speed, that the blue one is a fast right, the one is a fast left, sorry, the slow right, and the other two are the fast left and slow left. I can clearly segregate them. Only with the features I can clearly segregate them, then only the model is going to be really good for me. So I can do the features for classification. I'm getting a classification accuracy of around 70% over here. I'm trying to compare it to different algorithms available in literature. The details of what those are interesting. This will be more about and being able to predict hand movements recently. So the key line is the parameter, and the red line that I have on top is the estimated parameter. You can see the estimated parameter is very parameter that I should also click over. And such particular evaluation, we were able to have a very good performance. Please note that the novelty of over here, we used an emotive. Emotive is that 14-channel low-cost electrode that I mentioned earlier. And even using emotive, we were able to get this kind of details or this kind of accuracy over here. Please note that how am I verifying whether I'm doing it right or wrong? I just want to move back and let you know that I have an optical motion tracker connected over here. This motion tracker is making sure that I'm actually moving towards that direction or not. So this is not a movement imagination. This is actual hand movement. I'm not imagining, I'm actually moving my hand. And that particular one is captured by the motion tracker. So I will be easily able to calculate my accuracy because I can see what is the actual value and I can also see what I have done with the GUI, which helps me to calculate the accuracy in a pretty decent manner. So till now, we were talking about the motor-related skills. Now I want to move on to the cognitive. The cognitive section that we can do. Hyperactive syndrome, attention deficient hyperactive syndrome. We call it by the name ADHD, for which they're concentrating on. So here I have a BCI-based neurofeedback games for cognitive skills. All I'm trying to say is that, do you remember the EEG frequency plot that I had showed you earlier? I told you that there are different frequency channels, alpha, beta, mu. My beta channel would be much higher, and when I'm not concentrating, my theta channel would be much higher. So I'm able to differentiate between both of them pretty nicely over here. So here I'm trying to show what are the results before a particular neurofeedback game and after this neurofeedback game. So indeed, I was able to differentiate between the beta and theta pretty nicely, which indicates different students trying out with different kinds of low-cost EEG devices, trying to play different kinds of games. One is a bullet game, another is on all that notes over here, the craft game, another is a running game where in which the speed of the runner is being controlled by the brain signal. Okay, so all these things helps them to boost their attention and cognitive skills. Okay, the student is wearing a low-cost EEG device, and this one is a 5-channel device, not the 14-channel that we discussed earlier. The intention is that I have a yellow obstacle on the center. This is a robot, and he is communicating with the robot via Bluetooth. So the brain signals are picking up his intention, whether he wants to move right or move left, and then the robot via Bluetooth, and just have to move around this obstacle, avoiding the obstacle. That's what he needs to do. Since I'm not able to play the video, I'm just showing you different snippets of the same thing. to avoid the obstacle completely over here with the help of just his brain thoughts. Till now, we're working about the exciting part of a motor and the cognitive version. I just want to give a wrap up by also telling about the emotional version. There are who are not able to emotionally connect with things. So an emotional recognition stress is good at sometimes your stress detection, and stress is bad, we call it to be the distress. Okay, I'll try to give an example for you stress. You are stressed before on the emotion over here. Is there anything that I need to know? Am I exceeding time?
No, ma'am, no, ma'am.
Okay, thank you. So this is just the experiment setup that we have tried to do, and students need to undergo a stress test. Stress test is they will be stressed to a level. Initially, it will be a stress which they can handle, but later on, the stress would be very difficult for them to handle, such that we can classify. So this is the protocol, and we have several testers. The first one that I have over here is called as the Stroop test. Over here, what is the color of each word shown over here? Even though I have written red and yellow, the yellow is not given in yellow. The yellow is given in red. So I just need to say what is the color of each word. So this is actually red. So, and the other one, or this is actually pink, the other one is green, this is blue, and this is black. So I should go for the third option over here, and that I need to do within few seconds. And the seconds will also reduce at different levels that I have. I also need to do calculation and symbols, memory, and things like that in order to stress the person and identify between eustress and distress. We were able to find that we can classify them pretty nicely if I just take the beta and the alpha and theta frequencies of my EEG, and the classification accuracy can be close to 77.6% over here. So all I just wanted to let you know is that this is a huge area where in which a lot of work is happening, and it is not just based on stroke rehabilitation or things like that. You can even think of games that can be controlled using mind signals. You can also think about more informative ones, like how can you classify between one emotion with the another just by reading your brain signals. If we can read our brain signals in that good manner, we don't need to even communicate, right? We need to have a connector on our head. Someone else be able to read what is in our mind. That's even a good way, but not for me. I love chatting. So I don't think that's good for me. Okay, so these are some of the publications that I have referred, some of mine. Before I end, I would definitely love to give an acknowledgement to all those people whom I have worked. Dr. Vinod was my PhD supervisor, and he is currently a professor in Singapore Institute of Technology. And a few of the research staff, they are also with. And I cannot say enough of them. And each and every one of us has contributed equally to this work. Says I'm just a representative presenting all their work in front of you, such that I feel that I can motivate at least one or two of you to think in this particular direction. That's all I have for today related to this talk on an overview of brain-computer interface. I hope I was able to give some new information into this particular field. Thank you very much. Thank you, Devi ma'am, for giving me an opportunity to talk to the faculty and your students over there. I was a student of Devi ma'am, and I still remember the college days wherein which we used to be very afraid of her. Thank you very much.
Thank you, ma'am. That was so insightful. And before we wind up, now the platform is open for interactions and discussions. So if any one of you have got any queries or if you want to add something, please feel free to unmute your mic.
Before I conclude, let me say, even though I said afraid was in terms of a respect-based afraid, okay? So we always wanted to be in her good books. That's why I said afraid in a respect-based, not another afraid, okay?
Okay. Thank you, Smitha. So actually, this is what is to be named as a motivation session for students. Actually, when you are referring me as your teacher now, so you are motivated, and then keynote speaker when you are with us now. So I'm feeling that I have to continue as a teacher. Now let me ask you one question in a layman point of view, because this is not my area actually. So the question may not be up to the mark. So actually, as one of our student, recently, before 1 or 2 weeks, she took break of study. The reason was she was not able to sit even for a few minutes. Certain minutes only he can sit and attend the class or whatever it may be. Throughout, his pattern is like that, not able to sit for a long time and attend anything. But when he was able to sit for some time, he will do the things neatly. And because of that reason, they are taking so many treatment like that and all, but the doctors are not giving them some positive treatment aspects. So a little bit I was worried from that day onwards when I heard it. So from through your talk, I came to know that there can be chances so that this kind of excitement throughout, because he was not able to sit properly for more than 2-3 minutes. So if that cap something you told now, if there is any chance for such patients?
There are 2 points for this. One is actually this pandemic has created a lot of depression in the youth, and that is also one among the troubles that we are seeing. And not able to concentrate is because of the proliferation of the amount of data that they need to see in front of them. So it's like, even though they are watching a lecture, there may be a side window open for something else. So they're not able to concentrate really well. So this lack of concentration is something that we can try to help with these kind of technologies. But we need to find a sweet spot, what excites that person. So only that thing that excites the person only will be able to capture him for some time. So if he is getting some reward for anything that he is doing, so it's a kind of a reward-based system. So when I said about the games, it's like when you are getting something, you are gaining points, or you are killing a monster, things like that. So you are excited in doing that, so you can keep your concentration for a longer period of time. So when you're keeping your concentration for a longer period of time, you're actually training your brain such that you'll be able to take this and use it for any other applications. So even for your study, you are able to use a longer attention span for yourself. So this is just training your brain to have a long attention span, or way wherein which your brain trained in a proper manner. That's all.
Okay, so actually, where we have to take them. Actually, I'm meeting doctors, and their guardian was totally disappointed. He won't be coming back. But where the person, when attending, he is grasping, but not extending for more than 2-3 minutes. So I don't know whether it is a by birth problem, but for the time being, he was a student
It's
who
not.
got full A plus in 10th standard, it seems. So that is worrying me.
It's not a by birth problem, ma'am. It's not a
Not
by
a by
birth
birth
problem.
problem.
It is just a created
Yeah.
problem. Actually, if the student, along with a good, uh, I don't know whether the notion of psychiatrist back in India is still a bad notion, but over here it is pretty much in every university over here we have a wellness center wherein which a lot of psychiatrists are working along with the students such that they would be able to understand how the student mind is working. It's very important for psychiatrists to work along with them. So back in this pandemic days, the wellness center is overwhelmed with a lot of students because of all these issues, even over here.
Okay, so let us be hopeful. I'm waiting for the day he is coming back to our institution. Okay, thank you, thank you.
Somebody raised a hand. If they have any questions, please let me know.
Fatima, you've raised your hand. Do you have something to say, or was that by accident? Fatima, are you there?
It's okay, just to add, you don't have to ask questions related to BCI if it's a new topic to you. You can even ask about how can you get internships with overseas universities, or you can even ask about how to try to go for a master's or for a PhD in outside universities, things like that. It's okay, because I know that this is a session wherein which students are trying to get as much information as possible.
Thank you very much, ma'am, for your informative session. Even though I'm a layman to understand, I'm on the civil engineering side, and whatever way I try to understand, I understood your talk, and how about your research on the Indian scenario, even though you are at Nanyang Technological University, and did you put any effort on doing research to the Indian scenario, because scenarios will be different in the different parts of the world, and did you try anything on our own country?
Okay, ideally speaking, I don't have a partner back in India, but my professor, Prof. Vinod, he was with IIT Palakkad earlier, and he had a very strong connection with NIMHANS, and we used to work with NIMHANS back in India. And what is the wonderful thing about India is that compared to Singapore is getting patient, because all that I have discussed right now is related to rehabilitation of patients. Getting patient data over here in Singapore is much difficult. A lot of personal protective rules and things like that. But individuals participate in the scenario and keep it a kind of a rehabilitative technology along with NIMHANS such that it could help stroke rehabilitation for them.
Hello.
Hello.
The
Hello.
I'm Jacob John. Science. Uh, is so
Uh, there are different kinds of internships that they can look for. The difficulty with overseas university would be in getting a kind of a scholarship-based internship. Many would be interested in getting students to do that. The slight difficulty that we are all facing right now after the pandemic is processing the visa for those students, because things are not as back to the normal. Previously, it used to be very easy for students to just apply, and if they are not looking for a scholarship, they could easily come over here on a technical visa for 3 to 6 months and work over there on that platform and could gain knowledge related to the same. Some of us are even trying, like because of the difficulty in getting people over here, we are even trying getting students remotely such that they can work over there, and we would be able to share the knowledge with each other.
what about online, ma'am? Is there any options are there?
Online in the scenario, it's like completely online internship.
Yeah.
There are, only thing is that you need to see, all of us will be pretty much busy with their own work. So just wanted to highlight that if you are interested in certain things, if the student is also able to portray their interest and work towards that particular goal and show some result towards that particular goal, definitely the researcher will also be interested in collaborating with that student and would be able to work towards a particular one. That will not be a trouble. Only thing is that you may have to email. It is a daunting task to email a lot of people asking them whether they are interested. But whenever we are emailing, we should be in a position such that you have a good LinkedIn profile or you have a good GitHub profile wherein which you can showcase what you have done earlier, such that that person will also be interested in working with you. So it is a very good strategy to have a very attractive GitHub profile and or a LinkedIn profile. So it's a culture that students have to work for themselves in order to make themselves sellable.
Okay. Ma'am, the reason for me asking you is that so the IIT Kanpur, so the director of Icet Academy, he called me over there, and they were ready to train our students in internships online for around 200 hours plus. So so mostly the classes will be in the evening hours after the college hours are over. So the students will be able to identify, share, what you call, separate some time for that, so that they'll be having a one-on-one session with the trainers as well. So that at the end of the day, after the internships are over, they'll be able to enter into others, apply for any jobs with regard to on the information technology side, either in
There
Infosys
is
or
a
Wipro
cell
or
by the name
something like that.
India
So is
Connect
there any
in
cell in your
NTU,
college
and
that
that
they
is actually
go for
working
online
with
training as well?
Indian universities. I'm not so sure how they are
Okay.
working with that, but I used to get internship students via email, and some of the exciting ones I may be able to take it up. It also depends upon whether I require a person at that time and the email also coming correctly at that time, and then I will be able to take them. Fortunately, I was able to take at least 2 to 3 students every year, so that would work to some opportunity in that particular thing.
Thanks. Yeah.
Thank you.
How
Truth is, dependent the process would be updating that in their this so able at or
Thank you, Mother.
Good morning.
Good morning, Smitha ma'am. First of all, I express my sincere gratitude towards you for your wonderful interactive and informative.
Thank you.
I'm Shabina, MTech student of this college. I have to ask you one question that after completing our PG and all, for applying this PhD, which universities are better and also I'm in the field of computer science. So which all subjects will be more relevant to take PhD?
Depends on your area of interest too. About the what kind of project you have worked in your master's level. You can actually leverage that particular master's project to pitch in for your PhD for any overseas or Indian universities. We have to be highly motivated to keep on chasing the supervisors, because there is you can apply through the normal stream of applying to a university. That will be called as a common pool of applications to a university. And when a supervisor is looking for a student, if he is not getting any other student, he will go to the common pool and search for a student. So that is considered as a last resort by the supervisors. For them, they are looking for more motivated people who are constantly behind them in order to get a position with them. So they might have already asked for an internship with them, or they might have showcased that they are good in this particular field, such that their profile is so good that this person is ready to take them. So you can directly contact them via email. So all of us are getting at least 5 emails per month related to whether they want to do a. So some of them just clicks. It's like it's a factor of time, it's a factor of luck, and everything comes together, because I need to have a project, and I should be looking for somebody in your domain. And then if you're sending an email and if everything matches, then yeah, it's a wonderful click. So these are things which happens for most of us. We will be searching relentlessly towards multiple channels, and one of them just clicks for us. We cannot say that only one thing we will be able to, then we should be really good in that area.
Okay.
So try as much as possible, and try with several universities related to this particular domain. And definitely, while you are trying to draft your email in such a manner that you are not sending the same email, the same resume to every one of them in the similar domain. Nobody will be interested to open up that particular one, because we can also see that it is a bulk email that you have sent. You're not really interested in that particular thing. It is just a bulk email that we are receiving. But when you're concentrating on a particular work, you have gone through the work of that particular professor, read some papers of that particular professor, you wanted to work with them, what you have done earlier such that it matches with that work, you are actually letting the professor know that you are serious about that particular one. Okay, so you need to do a little bit of homework before you send an email to them. They can okay.
The question or anything to discuss? So if want to ask any question, let me. It is a question. I was just wondering, has the medical field applied in jobs?
Yes, definitely. That's been applied in several domains of the for the field of brain development, especially our sensors and I don't know whether you heard about it, which is the BCA initiative in US, wherein which he is able to decode. He can write things using his brain signals in a much faster manner. So he just need not use his hand to write. He just need to use his brain to write. So those things are pretty much tried out and tested when you have a sensory array medically placed inside the brain. But with EEG, kind of a non-invasive way, yes, there are several missions that has been started up and is being used for stroke rehabilitation. Even over here in Singapore, where the Tan Tock Seng Hospital, we do have a rehabilitation center over there.
Okay, ma'am. Thank you. So, what about India, ma'am?
I don't know the exact scenario in India, but I know that NIMHANS has a particular set for that particular one. I have spoken to one or two doctors over there, so that's how I know.
Okay, ma'am. Thank you. Thank you. That's wonderful.
Definitely, Sri Chitra also may be having something, but I have no knowledge related to the details related to that.
Okay, ma'am. Thank you. So I guess that's the end of the discussion session. Now, we humbly request Smita ma'am to receive our token of love for imparting such a wonderful session on brain-computer interfacing.
Thank you very much.
So that's our token of appreciation, and this is a moment of pride to announce that this is a work done by our third semester artificial intelligence and data science student of our CET, Adarsh Narayan. Applause to you, Adarsh.
Thank you very much, Adarsh. I never knew I was that beautiful.
So this is our specialty now. Yeah.
Thank you very much, sir.
Thank you.
And we hereby virtually present the certificate of recognition to Dr. Smitha. Ma'am, you're so elated and equally elevated to listen to you all this time. It was so insightful, it was interesting and informative. You explained it all in a kind of zeal and zest, and that I'm sure that the participants over here was able to capture everything, like how will it be useful in medical field, how BCI game controllers work, how can it be useful in even recognizing stress and emotions. Thanks a lot, ma'am, for that lovely lecture.
Thank you very much for the opportunity.
Thank you, ma'am. Thank you very much. Being not been planned actually, and to bridge the gap, I just have this in my mind because I have completed my PhD, and I thought I can share the ideas for our younger generation faculty members to have an idea of doing their PhD, at least to start with. Yeah. Shall I continue? So the topic is nano in hydraulics. And here everybody knows the nanotechnology application. Am I audible?
Yes, sir, you're audible.
Yeah. Indu ma'am, if the second speaker joins, the keynote speaker, kindly inform me. I'll
Sure,
just,
sir.
okay. See, everybody knows that nanotechnology application in all fields of engineering, right? In the field of computer, and in the field of medical field, or in the field of electronics, the sensors, and all such things. And we, as a civil engineer, and we always look for the nanotechnology applications in the field of concrete technology. So this is a usual way we do. So the nano applications, continuing the nano materials, changing the nano material applications in the field of concrete technology, replacing the material, the normal concrete materials with nano materials. All right. So this is the way we used to think and do research in large areas in this concrete technology. But this particular area, the nano hydraulic, it's a different area, and which we can compare the nano issues with the easily my is responsible for how to search problem for that teacher or heavy rainfall. That's a start. And the next cycle as enough occurs. So this is a normal one. Whenever the rainfall falls in excess, then automatically the surface runoff, the water flow in rivers or streams or whatever canals and everything, it is in excess, the flow may occur. And in continuation of that, here what happens here is the dams overflow. And recent past, we can say our ancestors, they have constructed so many dams, and our engineers' part is to only take care of those dams, right? And now, if you start thinking of about constructing a dam, the crores and crores of money we may have to spend. So instead of spending so much of crores of money in creating the structure, and our duty as engineers, young budding engineers, there's so many technological developments has occurred, and our duty is to safeguard these dams, right? Safeguard these structures which was created by our ancestors. And once again, I'll go back because the people may not observe quickly. So the first slide shows here is during heavy rainfall and excess surface runoff occurs, and in continuation of that, so what happens here is when excess runoff occurs, even during floods, then the dams overflow. Then we may not be knowing what we have to do with that excess overflow runoff. Immediately, everywhere the shutters will be opened, and lot many damages it is happening to the society, either in the form of villages or in the form of agricultural land. So everything it is happening, it is damage to the society. So our engineers' part, what we have to think of to safeguard all our structures, to safeguard all our humanities, to safeguard all our society. So that is what our duty here is. So here, once this dams overflow, what we may have to do, the next step should be which leads to the dam failure. Once the flood occurs, automatically, even though the shutters have been opened, when it crosses its limit, we used to call it as the full reservoir level. So once this reaches full reservoir level, automatically the dams leads to failure. Dam failure may occur. So that is the final output here because of the natural disaster. Even if we can say because of the natural disaster, this dam failure may occur. So this is a natural phenomenon. Now, coming to this point, the next thinking how to go far, what are all the solutions we have in our hand, right? We may have very many solutions. I can say in one part of it, in what way we can go for the safety of the dam structures, right? So the safety of the dam structures in the sense like what are all the materials or what are the methods we can adopt. The technology also we may have to involve and see that we are not disturbing the dam structures, we are not disturbing the system, what has to be followed over there. So here my thinking or my research area, so I apply this nanoparticles or the nanotechnology into the hydraulics area. So this is where one introduction of a new area into the field of civil engineering has occurred. Now, then the nanomaterial, the next slide, this gives an idea of the materials, right? So the moment I said nano, say the nano, here the material I have to choose for making the exterior surface smooth. To make some illusion. So point here is by introducing the nanomaterials, we can make the surface of the spillways smoother, so that it increases the discharge in the spillways. Automatically, what happens when you are able to release the more amount of water through these additional structures which is provided in the dams, especially during the natural calamities. So what happens here is we can able to save the structure. See, point. Yeah.
Yeah.
Fine. I also made a conclusion here. So my aim here is to enhance the discharge in the spillways as well. We may have to safety of our dam structures. These are the 2 points. The research point. I'm just keeping it in all our minds, and probably the young budding engineers and young teachers can think of in different directions to apply the field of application of nanotechnology in our field. Thank you so much for the opportunity given. Yeah. Thank you, ma'am.
Thanks a lot. Thanks a lot for that, for bridging that gap. I guess we are the keynote speaker has arrived, so we'll have to continue the session. We are honored with the presence of another special person, Dr. Chithirai from Selvan, Head of School, Science and Engineering at University of Ghana. Professor Chithirai from Selvan obtained his bachelor's in Introduction Engineering, master's in Computer-Aided Design and PhD in Mechanical Engineering. He has over 20 years of experience in teaching, educational assessment, classroom management, and student relations. He also has hands-on experience in designing and implementing practices in the education sector, including interactive and innovative training and education content for engineering students. Professor Selvan has published more than 100 research articles in international journals and conferences. He has been invited and honored as keynote speaker, session chair, resource person, and technical committee member in various conferences in the UAE, India, Thailand, Malaysia, UK, Germany, and Italy.
He joined Curtin University, Dubai in July 2018 as head of the School of Science and Engineering after serving 7 years at Manipal University and 3 years at Amity University, Dubai. Sir, I humbly invite you to throw some light on the crucial role of engineering for sustainable development.
Thank you for inviting me.
Yes, sir.
Let me
Welcome.
share my screen. Can you confirm, please? Can you see the screen? Hello? Can you see the screen, please?
Yes, sir.
Yes,
It's
sir.
possible, sir.
Yeah, thank you. So, thank you all for joining this meeting. My name is Selvan. I am the Director of Research and Head of School of Science and Engineering at Curtin University, Dubai. I am going to present engineering for sustainable development. University, Curtin University is a university to be we are one of the top number 2 in the world for minerals and mining engineering. Top in the world for that. And we are the university. Campuses in Australia, Malaysia, Mauritius, and in Dubai. By the establishment of this body, and first graduated recently. Apart from engineering, we have management. So this So we start with this slide. The population growth in the beginning of 20th century, we were about less than 2 billion people. Today we are almost reaching 8 billion people. In 2050, according to United Nations predictions, we will be around 9.6 billion people, and 2070 it will be around 12 billion people. Population is growing, and the consumption pattern is also increasing. Let's consider our grandfather, grandmother, how much material they used and how much we are using. They did not have washing machine, refrigerator, mobile phones, laptops, internet, and so many other materials they did not have. And grandfather's grandfather, how much material they would have had. So when we compare 100 years before, one human being, how much resource means not only food. I am talking about all the resources, including water, material, energy, etc. 100 years before, how much materials one average human being had. Today, we are consuming, one person consuming around 1,000 times more than that. That means 100 years before, 1,000 people lived in the planet is equivalent to 1,000 people lived now is equivalent to 1 person. That is the scenario. So population is growing, and the consumption pattern is also growing. We need development. We need therefore to meet the demands of population, to meet the demands of human beings. We need development. We have a huge level of comfort and conveniences. So whatever development happens, that development that meets the needs of the present without compromising the ability of future generations to meet their own needs. We are currently consuming 1.7 planets equivalent amount of resources. That means we are consuming 70% more amount of resources than we are supposed to consume. We are consuming 70% amount of resources from our future generations. We are living on a stolen resources from our future generations. So the sustainable development means the development should happen without compromising the ability of future generations to meet their own needs. Sustainability, it is the goal, end point of the process of sustainable development. Now, why engineering? Why engineers are required for sustainable development? Because engineers only implement the government policies, mining activities, manufacturing activities, processing of materials, manufacturing of materials, maintenance of materials, all our engineers are involved. Soon after the 1992 Rio de Janeiro Summit, United Nations Conference, engineers, a group of engineers found that there are 2,500 issues in Agenda 21. In that 2,500 issues, 1,700 seem to have engineering or technical implications. And out of that, 241 appear to have major engineering implications. Therefore, engineering is very much required for sustainable development, not other professions. Engineers are highly involved in sustainable development, and we need to involve in sustainable development. I did not talk about this much, but let me give a brief idea about greenhouse effect. These are the greenhouse gases. Some amount of heat energy is absorbed by the land, earth surface, and then reflected back to the space. When they go back to the space, the energy density is low as well as the wavelength is more. Therefore, they cannot penetrate, they cannot pass. So the entire heat will be trapped within the earth. Therefore, there is a high heat. This is what is global warming. Now, these are some of the global perspectives. I think you might have seen these news articles. The Earth has endured 14 straight months of record-breaking heat. United Nations Weather Agency, 54 degrees Celsius in Kuwait, maybe the Asian world record. You can also see last year on 6th of August 2021, Turkey marks 10th day of forest fires. Homes destroyed in Greek island. 100,000 people to evacuate in California. And British Columbia, 100 people died because of the bushfire, forest fire, bushfire in Australia. Even if global warming stays below 1.5 degrees Celsius, 40% more land could burn. This is the current scenario 2 months before, July to August only. The UK is not adapted to the high temperature seen last week, BBC News. Climate temperature increase in Spain, you can see all this. So this is all happening. So this is because of the climate change. And another one is flood in Germany last year, flood in Bangladesh, flood recently 2 weeks before in Pakistan. 1 year, how much water, how much rainfall should happen? That happened in 2 days only. 2 years before we have seen in China, how much water, rainwater should come in 1 year. It came in 2 days only. So this is all happening everywhere. California is burning, Spain is burning, Turkey was burning last year. So all these things are happening because of climate change. Flood is a reason, because of climate change only you have flood also. Because more temperature means more seawater will become vapor. Not only seawater, water on the land also will become vapor. So more vapor, more cloud is formed, therefore more rain. That means because of this climate change, seawater comes to the land. That is the problem for climate change. For every degree of global warming, 1 degree extra, 7% more water can be absorbed by the earth. So the water may lose, the world may lose half of its sandy beaches by 2100. It's not too late to save most of them. Another reason, drought. This planet is not only for human beings, this is for every species. So now we can see extreme drought in Kazakhstan, New South Wales in Australia. There is a big drought. Lake in Nevada, July 23rd, 2021. And this is all happening everywhere. Average temperatures are rising by 0.3 degrees Celsius every decade. Some 42% of California's population is now under drought emergency. This is not only California, everywhere, all throughout the planet it is happening. You can also see this. Glaciers are melting in Greek island, Antarctica, many parts of the world, even in India, Himachal Pradesh, Uttarakhand. The glaciers are melting, ice sheet is melting, Once they are melted, they go into the sea. So the volume of water in the sea is increasing, sea level is rising. Sea level is rising, therefore we are losing our land. Every year we are losing our land. Population is growing, we need more land, but the other side, still we are losing our land. So I Okay, so let me continue. Snow cover is ready. So this is all planned shift. The other indicators of loading poleward and upward. Spring comes earlier. Sea ice level in the sea is reducing. Ice sheets because of high temperature reducing in the sea level. Sea level is rising. Sea surface temperature is increasing. Air temperature near the surface is increasing. Temperature over ocean is increasing. Humidity is increasing. There are many other health related issues. So this is all because of climate change. Currently, we are consuming 1.7 planets equivalent amount of resources. In 2020, we were consuming 1.5 planets amount of equivalent amount of resources. By 2050, we need 3 planets amount of equivalent amount of resources. So if you go, the business is going as usual, then we need 3 planets equivalent amount of resources. Therefore, there is a rapid reduction here. Here only the engineers have to work on this, because by having energy conservation principles, sustainability principles, engineers can work on this to have one planet. Even if you go to Mars now, that is not enough, that is not sufficient, that much amount of resources we are currently consuming. So what is the problem? Why it is happening? It is all because of human activities. Human activities is the problem for climate change, because more amount of consumption, more material, more manufacturing, more industries, more IT, more usage of materials, more food production, more medicines. All these are happening because of that only we have a huge amount of energy conservation, and that energy comes from fossil fuels. Therefore, now let's talk about some of the resources. The most important resource, the most consumed resource in the planet is water. Water is the only substance available in all the 3 states. We have solid water, that is ice, liquid water, and water in steam. For every manufacturing activity, we one day If tomorrow water is not there, then only problem for us. Manufacture short, we need about 3,000 liter making material to manufacture enough of water. To manufacture a jeans pant, 6,000, not only for that, 2 liters of water required. To manufacture a set of shoes, around 10,000 liters of water. The car, 400 liters of water. Even to manufacture a small sheet of paper, we need 6 to 10 liters of water. For we need water. 1 billion people have access to safe drinking water. Sanitation. So this is all happening through water scarcity is happening in parts of the planet. So we need to consider this water is the most primary resource, and many parts of the world have scarcity of water. Now you can see total global water out of the 96% which we can do using the base stations and industries. We need to start the water. That is the very only 2.5% in the 2.5% is that 68% don't is that increase of spot in 2.5%. That I some must be 0.5% biology lower 0.46%. That's what they're saying. 25%. So, second is energy resource. The size of the economy in any country is measured based on GDP. If GDP is good, then that country is doing very well. For example, GDP of United States is more, but at the same time they are polluting more. They are emitting a lot of greenhouse gases. India also emitting, but the population of India is more, therefore more greenhouse gases going out. So the developed nations overconsumption is the problem. For developing nations, population is the problem. 20% of the people consuming 80% of the resources, and the remaining 80% of the people consuming only 20% of the remaining resources. So GDP is measured the economic growth without considering the finite limit of world resources. But we have power of sun. The world's current power consumption is 18.3 terawatt. That means 18.3 into 10 power 12 watts. 1 terawatt is 12 watts. The incident solar power on the planet is 166 petawatt, 10 power 15 watts. So out of this, 30% is reflected back to space, and 90% is absorbed by the clouds. Those we cannot use. The remaining 85 petawatt power, solar power, is available for use. That only 85 petawatt is more than 4,000 times of our current world consumption. So very much is available for us. Only thing we need to utilize properly. We can very easily install solar plant on our buildings, on our homes, but we cannot have nuclear power plant or thermal power plant. We can easily maintain a solar rooftop. So it is all very much possible. And renewable energy, all the renewable energy resources are indirectly they are solar energies only. Because even if you see, consider wind energy, because of the change in the temperature, there is a change in the pressure of air, therefore wind comes. Similarly, hydro, bioenergy, wave energy, and there is also tidal energy available, geothermal energy. Underground, the temperature will be always constant. So we supply cold water underground, and then we produce steam out of it. That is used for power generations. These are all renewable energy resources. And I don't know whether it is right to present here, but you can see this also. There is a research results according to International Energy Agency to have net zero scenario in 2050. We have some projections here. Currently, 2015 to 2020 scenario is given in the solar PV. If you consider aiming for main case 2021 to 26, it should be about double of annual average additions in the solar photovoltaics. So if it is an accelerated case, then it is about 3 times. To achieve net zero by 2050, we need to have 4 or 5 times solar energy that we are using currently. Similarly, wind energy and hydro energy, we can see this. The other resources, hydrocarbon resources, 80% of the energy consumption coming from hydrocarbon resources. Oil, coal, natural gas, these are the hydrocarbon resources. Now, they are primarily used as fuel because their reactions with the air are highly exothermic. That means they generate a lot of heat. That's the reason we continuously depend on hydrocarbon resources. Because of these hydrocarbon resources only, fossil fuels come out, carbon dioxide emission is happening. Because of the carbon dioxide emission only, we have climate change and other consequences. Material resources, minerals, they are very majority of engineering material manufactured by the material resources. Bauxite, for example, it's a ore for aluminium, iron ore for ferrous materials. So these are all we are currently consuming. Not only these two, titanium, steel, gold, all these material resources we are using. 20 years before, how much before around 100 down, we used to get a amount of minerals. But today we need 400-500 kilometers down. Now we are not able to get all the minerals. If we get only very low grade minerals. We say Mother Nature. So these activities, these mining activities will happen in remote locations only. It will not happen in the center of the city because that will affect the living of people. Therefore, when it is happening in remote locations, we don't have power generation infrastructure there. We have to be completely on fossil fuels. Diesel generators for these main items. The moment using diesel generators, many items. Meaning the energy process down is a very energy intensive process, and we are not able to get all these minerals materials now like before. So that is again another problem. The global consumption of materials is increasing and is expected to reach more than 160 billion tons per year by 2060. Approximately 10 billion tons of engineering materials are produced every year. Steel, wood, concrete are the major engineering materials. Next resource is air resource. Air is generally not considered as a resource because it is abundantly available, but the problem is pollution, air pollution. Air is compressed and used in many industries like for pneumatic purposes or for cooling or using in a compressor, different purposes we use. The air quality is a concern in many countries around the world because of greenhouse gas emissions. Other material resources, sand, it is very important. It is the second most consumed resource after water because population is growing. We need to have accommodations, building infrastructures, bridges, dams, everything. So that is also the key ingredient for cements, concrete, roads, glass, and other electronic industries. Cotton, most widespread profitable non-food crop, accounts for 1/3 of the global fiber productions for textile industries. These are some of the other resources. Now we can also see the demand, sand demand and sand availability. The demand, this is the projection, we need 25 billion tons per year by 2100. But how much is available? Only 10 billion tons per year only available by 2100. This is the projection. And the sand price also is going up. So whoever is having more sand will be very richer people in 2100. That's the projection it's showing here. These days there are sand mafia, sand trading, exchange. All these are happening in illegal activities are going on sand. This is talking about the back to this linear economy to circular economy. I'll just play this video.
Living systems have been around for a few billion years and will be around for many more. In the living world, there's no landfill. Instead, materials flow. One species' waste is another's food. Energy is provided by the sun. Things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components. And in the packaging they come in, it can create compostable materials that help grow more stuff. As they say in the bit, no resources lost in the making of this material. So what about the washing machine, mobile phones, fridges? We don't buy. Yeah, talking about another subject. Valuable metals. Inequality used
Yeah. So this is another concept. That's about the circular economy. Instead of throwing everything to landfill, you redesign, remanufacture, reuse it, recycle it for more, and circulate in the economy. That's what is circular economy. Now, another concept is industrial symbiosis, regional synergies between the industries. This is the very iconic place located in Western Australia, Whainana Industrial Area. There are 106 interactions between 28 industries. There are 28 industries located, but between these industries, 106 interactions. That means the waste of one industry is going to the raw material for another industry. That may be a raw material for another 2-3 industries. And waste of another industry may be the raw material for another industry. Going on within the system. Therefore, we can avoid transportation system, we can avoid importing, exporting products, semi-finished products and other things. So this is again another important concept, industrial symbiosis. I don't know whether you all may have already have these clubs.
Yes, sir.
You can also
already we have.
Yeah, that's very good. So through this, you could be the leaders for sustainability. You can create awareness among your generations and future generations. That is very important. Now, in food court, coffee shop, and kitchen, light off when not in use, windows and doors closed when air conditioned, cooking equipment off when not being used. Use only sections of cooking equipment needed to meet demand. Kitchen hood exhaust fans off when not cooking. Avoid excessive use of hot water. Refrigerators, freezers off during holiday if not in use. Ice maker off during holiday if not in use. Meeting rooms and conferences, light off and not unoccupied. Storage room lights off when not in use. Theatrical lights off when not in use. Audio visual equipment off when not in use. Doors leading to the outside closed. Lifts, encourage people to use staircase instead of using lifts. Washrooms, in water conservation particularly, in washroom, kitchens and showers, install water saving nozzles. It is very much possible to save water. Whatever you are investing, you will get back money also. But put signs near the basins to remind everyone to turn off taps as soon as they wash their hands. Install low flow shower heads in every shower. Detect and immediately repair leaks so that the wastage of water can be reduced. Install dual flush into the toilets, putting signs to remind the proper use. Put signs indicating to dispose paper tissues in the bins rather than in the toilet. Always use a broom to clean walkways, driveways, and entrances rather than hosing up these areas. Use dish cloths washers only for full loads. Water conservation again in gardening and landscaping. Set up an automatic drip irrigation system for all green areas. Mulch garden regularly to log soil moisture. Group plants with similar water needs in a common area so that we can appropriately supply water there. Explore the possibility to adopt rainwater harvesting. Explore the possibility to adopt water reuse, separating basins drainage from toilet drainage. There are some waste management practices that I thought I can share. Encourage to use reusable drink bottles and lunch boxes. For example, our campus in Cotton University Dubai is a plastic-free campus. So something like that, you can organize a functional method to collection, putting in every area for plastic bottle containers, dedicated water plastic bottles used in offices, kitchen, food courts. Throw all the plastic bottles into the main container dedicated to water plastic bottles only. Organize a food scrap collection from offices, yards, and other canteen, and then use in the compost area. Paper recycling is also very much possible. Limit the use of printed documents and photocopy in offices. Provide recycling containers for and waste mixers, canteen, and other administrative areas. Set up proper in the use of laptop. Reduce amount of newspaper. So thank you for listening. I hope I have inspired you the important topic. If you have any questions, you can talk to me.
Really, sir, really inspiring only. This is the area that we want to hear again and again and again, because we have to get inspired and we have to transfer this to others. Because nowadays we are aware that the waste management is a very big problem. So I want to hear from you some ideas on plastic waste management also. So nowadays everywhere we are talking about it. So actually no management is taking place. It is taking place to a certain extent, but not in a fruitful manner. So I want to hear from you.
Yeah, this is also very possible. We can have instead of using water bottles, plastic bottles, use and throw bottles, we can have a glass bottle or steel bottles. We can encourage your students to bring water bottles from homes. That is possible, because not only that, it is good for health also, because water, particularly if it is stored in a plastic, then the micro structure of water is changing. That's the research shows. And the pH value is going acidic. So we need to drink alkaline water. It is 2/3 of our human body is water, and we need to consume a good amount of healthy water, not only clean water, but healthy water. That is very much important. If you avoid plastic bottles, we can do something good there.
Also nowadays, recycling of water is taking place. So what is your thought on it? The water is getting recycled and everywhere in malls and everywhere in flats and all. But being, I don't know, a little bit back, my thoughts, a little bit afraid to use that. But anyway, we are using that no other way. But what about this recycling of water and reusing it?
That is happening. Not only recycling, desalination is going on, reverse RO systems. All this, again, it is not nature. It is against nature. So recycling is okay. But when we consume water with RO system, people say there are different kinds of water, microstructure in the water is becoming very thicker. It is clustered based. So when you consume such water, it is not passing through the blood cells, and then because of that, people are under stress. Lot of tiredness, all these things are happening. There is, I don't know whether you are aware about it. There is a technology in Japan. It is called Gangan water. They generate, they generate water with alkaline water, and then the structure microplastic also very small. It is very easy to pass through the human cells, and then people are living healthy. People with diabetes, pressures, those people after consuming this water, they become very healthy. That is equivalent to Zamzam water in Saudi Arabia. In Bangladesh, there is a river that comes from glaciers. So that is all very good, healthy waters. So they have proved that also. So we can also explore those possibilities.
Okay. Nowadays they are coming and making us aware about it. Still, as we are not having full awareness on that, we are not moving forward. I heard about this. They explained to me and all. So still, so when I am hearing from you, I am more confident. Okay.
Thank you. Any questions?
Yes, sir. I'm Dr. Muthukumaran, convener of Icet. Yeah. Thank you, sir.
Thank you for inviting me. Right.
Yeah. Thank you so much, sir. Thank you so much. And I have a question, sir. Like in India, we have various systems to manage our water resources. And how
but the consumption is too much when compared to the water energy. COP28 Congress of the Parties, United Nations Conference of the Parties, is happening in Dubai next year in the Expo City.
Thank you. And in the present scenario, everybody is running behind the computer science and engineering. And do you think the mechanical engineers and civil engineers have a role to play in future? In the field of sustainable development.
Yes, not only mechanical and civil, all the branch students can participate in sustainability practices. Because what we do in mechanical engineering, we are running mechanical engineering here. Whatever project they do, whether it is a manufacturing project, design project, whatever project do, they have to write a chapter on sustainability. That's a mandatory requirement for us. So somehow they bring some relevant aspects in the sustainability, and then they do something on that. So that's what we are doing right here.
Fine. Thank you so much. Thank you.
Thank you. Any questions? If you have anything more, you can also contact me through Dr. Muthukumaran, Madam Principal Madam. So I will be happy to answer anything in future. Thank you so much.
Thank you, sir.
Any further interactions or discussions? Students from the part of students? If you have got any kind of queries, or if you want to add something to this, please feel free to unmute your mic, or else we'll move on to the next part of the session.
Okay, thank you for inviting me. Thank you so much. It was nice interacting with you. See you sometime soon later. Thanks.
Thanks a lot, sir. Now we have a small token of appreciation here for you. Please accept our heartfelt gratitude in the form of this portrait that we have here.
Thank you so much. Thank you. Thanks.
Sir, for your information, this is the pencil sketch drawn by your own student. Yeah.
Oh,
Yeah.
Thank you so much.
It's coming. It's coming.
Thank you, Adil Krishna. Thank you. Can you please share that sketch to me, please?
Sure, sir. Sure. Definitely, sir. Definitely, we will send you the soft copy as well. The hard copy, we'll try to send it to you, sir. Yeah.
Thank
Definitely, sir. We will frame it and then we will send it to you. In person, I'll hand it over to you when you have a chance to come to India and we will meet. And if time permits, you can visit our institute also. It's a very green campus. Yes, sir.
Very good to know.
Yes.
Thank you so much.
Yeah.
Thanks.
Plastic-free campus also, sir.
Yeah.
Very good. Thank you so much.
Thank you, sir. And we hereby virtually present the certificate of recognition to Dr. Chithirai Selvan. Sir, it was a pleasure to listen to your lecture on engineering and sustainable development, and that gave us insights on how to focus developing practical solutions. And you listed down various practices that all of us can try on, and you reminded us that good environmental practices can start from us. Thank you so much, sir, for that standing presentation.
Thank you so much. Thank you.
Now, I would like to welcome Amrita and Manu, Dean Academics, to address the audience. Amrita ma'am, are you there?
Is Amrita madam muted? What sound is coming?
Amrita ma'am, are you available?
Yes, we have seen her, but
Yeah.
no sound is. Okay, if any network issue, shall we move to the next procedure?
Yes, ma'am. Yes, ma'am. So we can continue with our next procedure.
Yes.
It is not joy that makes us grateful. It is gratitude that makes us joyful. I request Mrs. Savita Vasudevan, ICET 2022 coordinator, to propose the vote of thanks.
Thank you, Indu. Good afternoon, one and all present here. It's given me an immense pleasure to deliver the vote of thanks for this event to all the dignitaries assembled here. First of all, I would like to thank our CEO Salim sir for his words of encouragement and guidance. Then I take this opportunity to thank our beloved principal, Dr. Devi ma'am, who always provides right direction and motivation to us to learn and try out new ways to doing things better. Thank you, ma'am. Then I would like to
Thank you,
thank
sir.
our speaker, Dr. K.G Smitha, Senior Lecturer, School of Computer Science and Engineering, Nanyang University, Singapore, on the topic Brain-Computer Interface Systems, Overviews and Applications, and also Dr. Chithirai Selvan, Head of School, Science and Engineering, Curtin University, Dubai, on the topic Engineering for Sustainable Development for their valuable support. Last but not least, I would like to thank all the participants and my dear colleagues who made this session a big success. Then thank you all. Thank you.
Thank you, Savita ma'am. That marks the end of the morning session. The afternoon session will be department-wise lectures, which will start from 2 o'clock. So students can join through the links provided to their department official group. Thank you all once again for your support and for your patience. We'll meet again afternoon.
Okay, thank you, Intu, for nice comparing. Okay, thank you.